Diabetes can strike anyone, from any walk of life, and it does, in numbers that are dramatically increasing. Diabetes affects more than 34 million people in the United States alone. While the discovery of insulin in 1921 saved countless lives, it is important to remember that insulin is not a cure. Even when treated, diabetes can cause serious long-term complications for patients. At the Diabetes Research Institute at the University of Miami, Miller School of Medicine, our scientists are intensely focused on one single goal: finding a cure that will end diabetes forever. And it all starts here in our laboratories. This is where researchers like Dr. Juan Dominguez Bendala are exploring revolutionary methods in regenerative medicine to produce life-altering cells that can lead to a biological cure for diabetes.
We are basically trying to get new beta cells that make insulin for type 1 diabetic patients. We are trying to get stem cells to make new beta cells. Stem cells have the ability to grow in unlimited numbers, and then once you achieve that, you can teach them to become pancreas, the cells of the pancreas that make insulin. We are trying to tap into a source of stem cells that we have discovered inside the pancreas of the patients. We have found that we can stimulate those cells to create new beta cells that make insulin. We can perhaps give the patient a drug that would stimulate those cells to make new beta cells. And that's why what we do in terms of getting new beta cells for patients is so important in the context of finding a cure. I think that there's a critical mass of knowledge that has been achieved over the past 20 years that allows me to be very optimistic in terms of where we are going to be in 5 or 10 years. We won't stop at nothing to get a cure, but before we get to the cure, we'll get to treatments that can improve the quality of life of patients in a very significant way. The time to cure diabetes is now, because it's about time.
Inside our laboratories, we are harnessing the power of islet cells to help people with type 1 diabetes live without daily injections of insulin. Dr. Norma Kenyon is focusing on ways to transplant these life-altering cells without the need for lifelong anti-rejection drugs.
I've been here working at the DRI since 1994, pursuing my passion in immunology. I was always intrigued by this area of research, and it was cemented for me when my baby daughter went into a coma and nearly died from the onset of type 1 diabetes. You can transplant insulin-producing cells, and you can reverse diabetes so that people come off of insulin injections. But the challenge is the drugs we use to stop your immune system, your body from rejecting the transplant, have a lot of adverse side effects. When you suppress your entire immune system, you're more at risk for cancer and other types of disease. We started studying cells that we take out of the bone marrow. They're called mesenchymal stem cells. They produce several immune modulating factors. So now we're very excited because we think that we have real potential to eliminate the types of drugs that cause side effects. And our ultimate goal would be to trick the immune system entirely to think the cells belong there. I really see that field has come so far. It's incredibly exciting. Without donors to essentially believe in us and what we're trying to achieve, we wouldn't be able to test those cutting edge ideas to give us the building blocks to have that cure. To quote my late father, never give up, never give up, never give up.
Once transplanted, islet cells could begin to make and release insulin in the body, but they face challenges from the immune system. Dr. Allison Bayer is exploring novel therapies to prevent the rejection of transplanted cells and do so with less toxic immunosuppressive drugs.
I've been here at the Diabetes Research Institute since 2006, and my work really centers on what we call tolerance mechanisms of the immune system. The advances in my lab really center around a particular cell population that we call regulatory T cells. We want it to do its natural job, which is regulate this destructive immune response that's killing off the insulin-producing beta cells. Using experimental models to study the disease, we've been able to use this population of cells and cure type 1 diabetes. And so what we really want to do now is to move this to the clinical setting where it can actually benefit patients that are living with type 1 diabetes. We want to make a living drug. We want to use a natural way of resetting the immune system. Some of the hurdles that we have really still center on specificity. We want these regulatory cells to go to the pancreas, and we want them to love up on the beta cells and protect the beta cells. I'm extremely hopeful. I love walking through the door every day when I come to the DRI and doing research and making new discoveries with the hope of really helping patients that live with type 1 diabetes.
Diabetes is a chronic condition that impacts 463 million of us worldwide. While the number of cases is increasing, so is our enthusiasm and commitment to finding novel and effective biological treatments for this debilitating disease. We are continually pursuing cutting-edge ideas that will improve the health of humanity and the quality of life for so many of us. We look forward to partnering with you to continue developing this revolutionary and life-changing medical technology.